Today on the bench, I have a DROK DC to DC buck converter, constant voltage, constant current supply, comes with a little pamphlet, product parameters, description. Now this unit will take an input of 10 volts to 75 volts, and it says adjustable output voltage range 0 to 60, and it actually can be adjusted on the current from 0 to 12 amps. So 0 to 720 watt. So a really impressive little regulator. Got the fuse protection there. Got a really big inductor, a little cooling fan. So I wanted to try this little device. I do have the smaller one that I really like. This one opens up a little more opportunities as far as even equalizing a battery pack. My thoughts about needing something like this came up when I don't really have a good power supply that'll go above 30 volts readily. And if I get an issue with a battery pack, say even, for example, one like this, it's a 56 volt ego, maybe it's gotten unbalanced and don't want to charge right, I can actually power this from another fully charged good ego, and I can actually output. So I can actually constant voltage and constant current supply that pack until I get it up enough where the correct charger for it will charge it, or actually charge it correctly. So with that being said, we'll hook this up to a 56 volt supply or so and see what it does. So in about 2 minutes time, that made a really neat little portable power supply. Set in there just perfectly in the slots. But right off the bat, powered up, we got input protection. I got a meter just showing the output here. I'm realizing now on the screen this says 5.0. You really can't read that. Let me try this filter material. That's a little bit better. Light off. You still can't read it real well, but the filter does help. If I slide that on there, maybe that diffuser will help a little bit. 5.0, I believe that shows up a little better. So set for 5 volts. If I go OK, well, it puts out 5 volts. It shows output, constant voltage, and that one says constant current, CC, if you can't see it there. So just for basics, we got set 5, 1 point, I think I turned that into 1, I'm gonna put it on 1 amp. Current, voltage, I'm sorry, I'm gonna go up to 12 volts. That's quick. 12.1 is fine. Set. 1 amp. Okay. And there we go. 12 volts. Okay, if I hit set again, it does kill the output. I don't know if I could adjust it. I can adjust. Okay, I can adjust it when it's online. Just don't hit set. Set to kill it. Okay is on. Very useful. So I have this portable power supply set for 56 volts. Current of 1 amp. I'm just trying to get this this low battery pack up slowly. I can set it for a lot more than that, but I'm going to let it go. Hit OK, and it's going to show that we are at constant current. If I hit OK again, we're staying at that constant 1 amp, and you see the voltage rising there. Just got it temporarily hooked up to this pack across all 14 of these cells in series. So we have that battery voltage slowly climbing, which I feel more comfortable with, just slowly going up on those series cells. We still got that constant current 1 amp that I had set previously, slowly coming up, approaching 46, and I have set it for 56, so it's going to stay in constant current to keep that 1 amp until it gets up and drops below 1 amp, or that voltage hits 56 volts. And once it does that, it'll switch over to the constant voltage. So once it gets to that point, I'm going to stop it and put it in its actual ego charger and charge it up. Back with this DROK power supply, made into a little portable battery power supply unit. I have a bulb. It's a 60 watt 120 volt bulb I just soldered some leads on and have on here. Just makes a good load for the power supply, one that has this much output, rather than having resistors, trying to do some power resistors and letting them heat up. I thought, well, at this voltage we can even make the bulb glow a little bit. So when you have a 0 to basically 56 to 58 volt output, depending on the charge of this battery, it's a pretty wide range, and it's really, really handy to have. So I did want to show a few things about this power supply unit now that I have used it just a little. The instructions are good that comes with it, but they're not very explanatory on some things and some of the parameters and presets. When you go to set your voltage, one thing you notice about this power supply, it is handy how you can actually go to any range you need, but it only has one rate of update on the display change up and down. So it can take a while to go from 0 to 58 volts or so. So we'll go to 24 volts. It's fairly quick, but the one push 0.01 per push, it actually works really good. You can set the voltage, and we can go and set the current, which is not going to get above an amp. That's fine. And we go OK, then it puts out. And I got my meter hooked up to my output as well on some leads. And the bulb is just an indicator and also a true load. So if we actually take this and if we want to set this below, it'll actually kill it. We can step up the current slowly, and we see the voltage. Make sure you can see that okay. We see the voltage slowly climb. So the current regulation circuit seems to be working really, really well. And you saw it switch from CC to CV there, as it switched from the constant current to the constant voltage output. once it gets above, a little above 1/4 of an amp, it's just going to put out the constant voltage because we have it set above that on current. So once we got the output on, OK toggles between what we can select and adjust for the current and the voltage. Right now it's on voltage, OK, goes to current. Now if you hit set, it cuts it off. Where while it's off, you press set to go back and forth between current and the voltage, and you select it before you turn your output on. So relatively easy to work. And there's also some presets. You can do some presets and store and recall, and that actually helps quite a lot because it does store even after the battery power is removed. So this little processor is pretty sharp. It does have some memory features to it. So as we hit set here and cut the output off, we can go through what we want to set. If we hold down the set, it goes to F0, and it mentions in the little pamphlet that comes with it, if you want to do your parameter store, you actually press the up and down and adjust in the F0 and press OK, and the display SN0. I'm thinking that's like store number 0. Then you press up and down to select that address, and lastly press OK. So what that's saying at this point, if we do F0 and OK, then it asks us which store number we want that data to be at. But first of all, let's go and we'll set this voltage down to around 5 volts. And we'll store 5 volts as store number 0. All right, 5 volts, and we're going to hold set, F0, OK, store number. We can go 0 to 9. We want to do 0, the first one, OK. And apparently it shows Y for like yes. I don't know for sure, but it's pretty neat that it stores that. So now if we hit set and hold it down, actually, it's just F0. If we go to F1, it shows to parameter recall. We do the F1 and we go through, and I guess like LO0, I guess that's like location. So now we go to F1, OK, and go to location 0. We can go all the way through 9, back to 0. If we go to 0, well, it pulls up our 5 volts. Now, one thing I failed to mention is it also stores where you have that current at, so that's a really neat feature. It looks like it's a one parameter save, but it actually saves where you have the voltage and the current in that same storage parameter. So I have preset some others in here, so without boring you of going through F0 again, I'll show you F1 and go to location 2. I have it set for 12 volts. And again, if I go F1 location, I'm gonna go up to like 4. You can see I'm stepping on up. I got 36 volts. So you can do this however you would like, whatever voltage you like. And also whatever current. I have a 1 amp. I think by the default it comes to like 3 amps if you don't set your current here. So I set mine to 1 amp. That way I know I can adjust my current from there. Again, 6, 48 volts. So the way I had this at one time, and then I played with it a little bit, I had this stepping through, which made sense to me, from location 0 to, I think I used all the way to 8. And I stepped it up 5 volts, 6 volts, and I guess I could have started with a 3 volt, you know, depending on what you think you might use the most. And the more you use this, the more you remember it. But it's not the most user friendly, but it is pretty powerful. The main thing is, remember when you do set, that F0 was where you store it, and you got to go up to F1 to recall. Other than that, it's pretty straightforward. Another neat feature this power supply has is if you don't want this to be bumped or adjusted while you're doing something that may be important, whether it's current or the voltage. I know this might not be something necessarily on a battery that may be important, but if you don't want the power to go down, maybe you're charging a battery or something of that nature and you don't want it to get bumped. You want that, especially a lithium-ion cell or something of that nature, you want that current and voltage to be just right on that charge. You can actually lock this so it can't get bumped or even come on or cut off, or however you want to do it. It shows here how to start the lock key function. Press set key when cut off output, and then when it displays voltage, keep pressing the OK until it shows the lock, and that means you have locked the keys. So at this point on a voltage, we press OK and hold it, and it shows lock. So now we're locked, and we can't actually adjust. We can actually cut the output on and off, but we can't adjust anything. So we can go to current here on OK. We can't adjust that either. It's all locked out. So that's pretty neat. It's neat as long as you don't do that and then forget how to disable it. But to the actual end the lock, you do something very similar, but instead of being on voltage, you have to be on the current display. You basically do it the same way. It's got to be off. You go to the current display, and then you press OK, and now we unlock. So now we can make adjustments. We want to adjust just the current limit and ease it up slowly. We can see our voltage come up, so we can adjust all this like we have been. So I thought that was a pretty neat feature. It also mentions in this little brochure the communication addressing, that it has 26 addresses that's available. Now, I'm not familiar enough with this to know what that means. It must be some advanced features, and that might be something we can find online. I'm not really interested in that part of it right now, but I just wanted to mention that it does state that in the brochure. So I see that this little power supply board for the money has a lot of features, and it's very capable. So I've been really thoroughly impressed with it so far. So I just thought I'd show a little detail on the operation, and maybe we'll look at some of the components on the board, take a closer look with it powered off in just a minute. So the first thing I'll do before we take a closer look at this little DROK power supply board, I will take off the display board. I will just set it aside for now. Definitely trying to be aware of my surroundings and touching metal. I don't usually wear a wrist strap, but I do try to keep touching metal. Don't build up static. Not wearing a jacket, long sleeves, anything of that nature, because some of this is going to be static sensitive, especially on the bottom of this one. So as we take a closer look at this, I'm probably going to also take off this bottom heatsink so we can see the actual power transistors and diodes and things of that nature. All of these active components had the little seal pad, insulator, and heatsink seal pad, as well as the insulating bushing. So I did take note of that, a mental note of that anyway. So those have to go back on correctly. So now with the heatsink off and the small board off, I want to start taking a closer look, and I figured we'll start with this board. It's got some really interesting components on it. A little display board and hard to get the light just right on that chip. It is a 74HC595D. That one is really hard to see there. This is the information I found on that chip. I found a 74HC595. Says the 8-bit serial in or serial or parallel out shift register with output latches 3-state. So it does show some of the pin out there, what the description is. It is the 16-pin chip. On this we also have, looks like a little microcontroller. You can see that or not. Yeah, I think that shows up. STM8S103. So this is the information I have on that microcontroller on the STM8S103. 16 megahertz, 8-bit microcontroller, 8 kilobytes of flash, has EEPROM, which is how it's easily storing that data for us. That's neat. It has a 10-bit ADC, so it's got the built-in analog to digital converter. 3 timers. It talks about the UART, SPI, I2C. I highlighted the UART there because we saw on the main board in that bottom right corner where it says UART. See, next on the bottom of this one we also have STM17 STK17. It says 3.3 on that. It is in like a SOT89 package. The only thing I could find on the STK when I searched was from it was from AliExpress, and it mentioned the STK17 5.0, which would be the 5-volt version, and it says it's the same, or at least it listed with the AMS Won 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 7-5. Now I found information on the AMS Won 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 7-5-3.3, so going by that, I'm just assuming it's the same. It's the same as the AMS 1117 1 amp low dropout voltage regulator. So we have here the 3.3 version. It does mention that it can be in several packages on this one. Yeah, it actually don't show the SOT89, but it does show the SOT223, which that's more likely what that is. So I thought it was the SOT89. And it's also got a lot of the 1 AM transistors, which I know on this channel we've looked at those several times. It is just a little general purpose transistor. It's the NPN. Got a pin out. It shows the marking there. The 1 AM marking designates the SOT23 little transistor. 1 being the base, 2 emitter, and 3 collector. That's really it on this board. There is a lot to the back of the board, but the rest of that is really just a little passive. That's the only active devices that I see. There's the little number on the display, the LED display, if you're interested. If we start on the back of this board now, looking at some of the high power components, more than likely one of these is going to be our main current carrying transistor. V20100G. So that's D3. That's actually going to be a dual diode package or something. I'll look that one up. And this one here, it is really hard to get the light right on it. I believe that's a 045N, 10N. And then here, they're actually calling that T4. I don't know if a transistor or they're calling that Q1, D3. And all I see is a T4 there. But it is a BU406. All right, the BU406 is the NPN power transistor. It's for high voltage, so it is a 7 amp or 60 watt. And the 06 shows the it's the higher voltage rating one. Yeah, I see the E on both of those ratings. And also the C to B voltage is greater on the actual 406. So that's actually the T4 right there. That diode, similar to this one, it's got the 2100 number on the actual diode assembly. It looks like it is similar. It has the common cathode. You got 1, 2, and 3. So 2 will be the common cathode here. If we look at it from this angle, common cathode going to the transistor, and the 1 and 3, the actual anode, going to this anode on this actual diode, which is also the minus on the capacitor rail, so that main rail, input rail. And then lastly, the guy that's hard to see there, the 045N10N. I don't know if the camera could ever even pick that up. That's going to be our main carrying capacity MOSFET. It shows the pin out, gate pin 1, source is 3, and the drain on 2. So it is gate, drain, source. It shows that it has really low ohm resistance. That's in the milliohms. And the current up to 64 amps. So that is a high power device. It mentions up here about the very low ohm resistance. It's a really good feature. Therefore, it don't build heat when it is switching as much. Yeah, so that's the actual number I finally found, but it does show the marking being as on the chip, the 045N10N. So we have another smaller transistor right here on the board. That's not far from the T4. You can barely see the writing under there. It says T3 up under the actual component. So this T3 says it is a C2383. This is what I found when I put in C2383. It's the NPN TO923L package. It is emitter collector base. It showed some of the actual ratings and values of that actual transistor. As we work our way across the chips on the board, up in this more top left side, we have a 34063. And searching for that one, I come across a MC34063A. And the little SOIC 8 package, which is what we appear to have. It's a 1.5 amp step up down inverting switching regulator with a 100 kilohertz. So we have multiple regulators and parts of the circuit on this one actual power supply. Next up, that number is very hard to see. It's actually upside down there as well. I can see it better like that. EL357N. Little four pin device. Apparently a little photo coupler. A real similar little photo coupler. Just a little smaller package. One I had just looked up recently for the Ego 56 volt battery supply video. As we come on across, that's also upside down. That is the AMS Won 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 7, the 5.0 version. We have two of those right in the center of the board there, and those are going to be our 1 amp low dropout voltage regulators. We looked at this earlier as a comparison to the other chip, but we have the 5.0 version. The other one was a 3.3. Keep going the same direction. That is a J122G. And that's a D-pack, real similar to the faulty component we had on that 56 volt Ego battery on a previous video. Very similar sheet, the MJD122. Shows the pin out, D-pack. It's an 8 amp. The one we replaced and I bought some spares of on the replacement for the Ego battery I believe it was a 117 PNP, and it was actually only a 2 amp. So next up, TC1413C, little 8-pin. Actually a rather high output device for a small package. TC1413, 3-amp high-speed MOSFET driver. Shows some of the applications and some of the features. Functional block diagram. Here are the characteristics. We also have a chip here. If you look, there's a lot of flux residue on this chip, almost like it was replaced, but whoever did it did a very good job. I definitely couldn't have put it back on that well by hand. But there's so much flux around that chip only, like it's been replaced. A little bit different type package. Almost like it's not even a surface mount package, or maybe they added it later because of that, but I don't know if you can see that number, but it just says 0600, and then it's got a 1610 VHP, but I actually can find no information on that little thick 8-pin dip. Not sure what that chip is. Right there beside it, we see the precision resistor, the 0.005 ohm, 1%, apparently our current feedback resistor. As we come on down here, this is one we did find information on, MCP 6002I. We have one here and one here. They are the same chip. So I did find some information on the MCP 6002. They have several different markings there. And it is a low power op amp, 1 megahertz. Shows the package similar to what we have being the 6002. So that apparently designates the package, whether it's a 1, 2, or 4. Typical application. Few of the electrical characteristics of this op amp. And finally, what we have here is an XL Semi XL1509. We have one here as well as this chip here. They're both XL509s. And that's being a 2-amp, 150 kilohertz, 40 volt buck DC to DC converter. So it's got two of these little XL Semi buck DC to DC converter chips. So they do have a wide voltage input voltage range. It's actually a lot to the data sheet. I didn't print it all out. The pin configuration though. That typical application will help some, seeing how the feedback comes in. But I just wanted to quickly go over this board. It's such a lot to it. It's such a well-designed board. I definitely want to take the time to go over some of the components with you, and if you're interested to see how it's made and some of the components and the quality of them that they used. They definitely did a good job there beefing up the current carrying on the traces on the board, since this is a pretty high output unit, being rated for up to 720 watts and 12 amps. I'm going to put this back together. Overall, this board is just really a great bargain. I don't have a lot negative to say about this board. One thing that I would is it'll be an easy fix, but I wish they would have secured that inductor coil a little bit better. It is a rather large coil and it's an open board, but it's no big deal. The next time I have my hot glue gun with the that Gorilla Glue sticks, I'm gonna put a lot of hot glue around this to help secure it, just so it don't break off eventually. You know, just being an open frame like it is, it makes it a lot more susceptible to getting knocked off or damaged. But you know, it's got the fuse protection in. It's got a lot of current carrying capabilities. It's got a lot of functionality, even memory. I really think I'll enjoy using it, and hopefully I'll get a lot of good use out of the unit. So we got it all back together and working. Another thing just to mention, that ain't necessarily a negative thing, but any kind of switch or relay or even a manual connection, it does arc. This bus apparently goes across these caps, and when you actually plug up, especially when it's this 56-volt battery, it actually does arc pretty good when you plug it up across the cap. So it's typical for any type of buck regulator or switch mode power supply to be that way. Just keep that in mind, that a little cheap switch or probably even a cheap relay would be fine. Just the contacts would hold up well to that arcing, but just to make sure it's made out of good material. You got to make sure it's rated for at least 12 amps or better anyway, if you did add a switch, but just keep that in mind. Just amazed at what you can get for the money these days for power supply. I do want to bring up on the bench one of my first ones that I made and let you see how big it is. And I actually put a good bit of money in it, even though I used used components. I actually had to get this unit out of storage, no reason why. The size and the weight of this compared to the size of one similar to that, or even a little bench top. It's a regular little bench top power supply. It's handy. Don't take up a lot of room. Power it up. It's been in storage for a while. Put it to 12 volts. This is a power supply I put together with just used components that I had or had collected over the years. I know this little readout actually cost me a good bit of money back then, but I used the LED here for the power on. Did put a fuse and jacks, banana jacks. It's a little circuit breaker fuse. Later, I did do AutoCAD for the actual circuit that I used for it. I did have to have another separate supply for the voltage to go to that little digital voltage meter. I used the NF.Mini to do the voltage regulation. And I did this a lot earlier, but I think it was, 2004 is when I added actual drawing and actually added it to it for troubleshooting and information. But I used the old 24 volt DC, just regular 24 volt DC power supply, and used some old strips from this, I think an NCI old scale, industrial scale box that I had. And I had to add a little breadboard down there. You see the little 923 there. My little adjustment pot. Let me show you the transistors in the back too. There's the heat sinks in Q1 and Q2. MJ15011. The date code on those being in the 80s. 31st week of 87. Second week 83. So been around a while, but does work well, but unfortunately just so large, and these days it's just amazing just what you can buy. And it's fun to build it yourself, and I still build some little power stuff myself, but I tell you, just to have for the convenience and the current carrying capability, you really just can't beat this little DROK. So I hope you got something out of this little review of this DROK DC to DC converter. Just how convenient it is if you got a high enough capacity battery. and a high enough voltage battery, you can have a nice little mobile power supply out in the field to charge a lot of different RC batteries or things of that nature. It's even handy for the bench. It's easy to store, and it's relatively cheap. It's a well-made, robust unit. I hope I get a lot of years of use out of it. I hope you enjoyed this little look into the DROK. If you are looking for something similar or just another little extra power supply to have around, I think it'll be a good one. Hope you enjoyed this look into the DROK, and thanks for watching.